Question 68. After the ice was placed in the brine solution, before any of it had melted, the level of the brine solution was closest to. So what we essentially have here is we have a object that's floating in water, in this case brine solution, and we've got to figure out how much the volume will increase by. So there are two forces at work here. There's a buoyancy force and a weight force. So the buoyancy force is the force exerted by the water on this object, and the weight force is the weight of the object. So the buoyancy force is going to be equal to the volume times the density of that solution slash liquid times the GA, the constant, and weight is obviously equal to mg. One thing to know that you definitely have to know before you come into this question is the conversion, a couple conversions. So first one is 1 centimeter cubed is equal to 1 milliliter, right? And secondly, that 1 meter cubed is equal to 10 to the power of 6 centimeters cubed. So this is really important because our density is given to us in kilograms per meters cubed, but the sort of form that's very useful for us in this case, because we're trying to figure out the amount of mils that we're increasing our volume by. So the sort of units that we want is kilograms per mils. So in order to convert our brine density from 1,100 kilograms per meters cubed, we have to firstly convert it into centimeters cubed. So we do that by dividing by 10 to the power of 6. And so we now have 1,100 divided by 10 to the power of 6 kilograms per centimeters cubed, which is equal to 1.1 times 10 to the negative 3 kilograms per mils. So our density in kilograms per mils of the brine solution is 1.1 times 10 to the negative 3. Now that we know that, we can figure out our equation. So firstly, we set for the buoyancy force is equal to the weight force. And in this case, what we get is volume times, if we just sub in this formula, V times density times gravity constant, we get V times 1.1 times 10 to the negative 3 times 10 is equal to 0.1 times 10, which is the mass in kilograms of the ice block, and the gravity constant. So from there we get V is equal to 0.1 on 1.1 times 10 to the negative 3, which is equal to 100 on 1.1, and 100 on 1.1 is equivalent to 1000 on 11, and that's because 100 divided by 1.1 is equal to 100 divided by 11 on 10, which is equal to 100 times 10 on 11, which is equal to 1000 on 11. So 1011, if you do just your long division by hand, you get about 90. So our volume is therefore about 90 mils. Therefore, we increase our volume by about 90 mils, and therefore the correct answer for question 68 is B. Question 69. The level of the brine solution after all the ice had melted was. So we've got to figure out the amount of water that we're going to add slash the amount of volume that we're going to add if we melt all of our water. So every block of ice in this scenario weighs 100 grams. So we have 100 grams of water in ice form. And when that melts, we're still going to have 100 grams of water, but it's just going to be in liquid form. So there is this one sort of statement that always holds true, and that's that 1 gram of water, liquid water, is equal to 1 milliliter of liquid water. So therefore, when our ice block melts, we're going to have 100 mils extra of water, and that means that our level of brine solution is going to be our initial 400 plus the extra 100 from the ice block, meaning that overall we have 500 mils. So C is the correct answer. Question 70. So question 70 is pretty similar to question 69 in that we have an ice block melting into some sort of solution. It's just that this solution now is water instead of brine. So this does not actually affect our working out at all. Our ice block is still going to melt into 100 mils of water. So we're still going to add 100 mils of volume to our overall volume. meaning that C is the correct answer. So the amount of volume that we add due to this ice block melting is not dependent on what sort of solution it's sitting in. It just depends on how much the mass of water contained in that ice block, and in this case is 100 grams of water, which is equal to 100 mils of liquid water.